And for now, let's do this. So tonight what we're going to talk about is a continuation of last week, where we really did talk about how things are connected over the internet and the internet before the web, and the impact that has on the emergence of digital media and distribution. Okay, that's really what we talked about, was digital media and distribution. Tonight we're going to talk about digital media and connectivity, and to do that we really have to talk about the World Wide Web, HTML, and its associated technologies. Now, the course after this, which a lot of you took before this, and that's just the way this is weird, is more focused on web content in particular and its promotion. And these two courses go hand in hand. So, as I said before, there's always a little bit of overlap. To really promote web content, you actually need to know about digital media. And to understand how digital media is digital media, you have to understand how it's distributed and connected. So tonight we're going to go into connectivity just to make sure everybody understands the basics of how the web works. And the trivia for tonight, I actually learned this at Google this week. I did not know this. This is the statistic they said. They said it was public, so I'm assuming it's okay. How many hours of video data is uploaded to YouTube every minute? Any guesses?
I think you told us in our last class, 2205, something like that.
No, I didn't actually. I gave you how many
3,000.
No. This is every minute of every day, folks. How many hours?
3,000 hours a minute.
It's not. You guys are over. Evidently, it's only 500 hours of data every minute, right? Which is kind of crazy when you think about it. But that's essentially what the machines that run YouTube have to work on, right? There's 500 hours of data every minute, right? And I don't know whether you've ever uploaded something to YouTube or not, but it actually takes time for YouTube to process. It will add captions if you like. It will do all kinds of things. It actually optimizes that for streaming and all those kinds of things for you. So it's kind of an amazing computational feat when you think about it. Just to get that much data, right? Now, the average YouTube video is only a few minutes long. So how many videos is that? I guess we could figure that out if we figure out 500 hours divided by, 4 minutes, whatever that is, times every minute of a day. We'd end up with an awful lot of data. The statistic I gave you last year was from 2017, and that was that there is about 300 million hours of instructional video alone on YouTube. But this is all video. So the instructional kind, the kind that nobody should see, the kind that my kids watch all the time, and cat videos, everything, right? That's an awful lot of data. It's just an awful lot of data. It's mind-boggling, actually. So tonight we're going to talk about how that all works, because at its core, although there's a lot of other technologies on top of it, and if you want to talk about some of them, I'm happy to do it. If you want to have a couple of lightweight questions on it. At its core, the web is built on the technologies we talked about last week. It's built on TCP/IP, which is an internet protocol for sharing information. It's based on text files and those kinds of things, right? So I know that sounds crazy when we're talking about movies, but it really is built on that. So tonight what we have to do is talk about client, servers, and code, particularly markup, okay, and how that fits. And out of that, at the same time, we're going to answer what is the World Wide Web and how is it developed and governed. Last week I was talking about the internet, but not really the web. I mean, we ended talking about the web and how accessible things are, but we didn't really talk about what the web is, how it was invented, how it gets exploited, and how it is becoming how it's evolving into something else again, right? And then finally, we'll talk a little bit about digital media and HTML and connectivity. Okay, that's the main part of the lecture tonight. And then for the second part of the class, I'm going to let you have time to actually work on the HTML tutorials that are on the course website, and we'll have a look at that as well before I let you have that time. Normally, I would let you have that time right in the class, in the lab, while I can walk around and actually answer questions and help you guys out if you've never done this before. But I don't know how many of you have actually done HTML. I know if you've taken 2205, you had to because I made you do it. But that was the first assignment, actually, make a website. But tonight, for those of you who haven't done it yet, I hope you get your feet wet actually creating some web content so you can see how connectivity is not exactly the same thing as distribution. Okay? It's a subtle difference, but it's an important one to understand. Okay, so let's start here. This is a picture I blatantly ripped off of Wikipedia. Since it's open source, that's fine. And in fact, the information about this is linked on the class website to Wikipedia's entry for client servers. So I want to go back before the web again, right? No web, there's just a network. In fact, if this was a mainframe, if you get rid of that word internet, right, this actually works a lot of the way that those old mainframes worked. You have a central computer, which forms the basis of being a server. And, you know, back in the day, back in the 60s and 70s, you would actually have dumb terminals that you could call clients. They weren't very smart clients, though. They couldn't do very much with information. All they could do was show you what was on the server and nothing more. Okay? So is everybody sort of okay with that? A client is something that gets information from a server. Okay? And a client is a computer or a computational device, some kind of computational device. Okay, you see a phone, a workstation, and a laptop, but it could also be a light bulb that has a computer in it, a refrigerator that has a computer in it, anything that's got a computer in it, you know, a wristwatch, whatever, right? They're all clients for information that resides on a server, okay? And some of the things we saw last week with the internet were absolutely client-server applications. So mail, email, right, does not require the web. If your client is Outlook, that is a mail client. It needs to go to a mail server to get the mail information, right, that is addressed to you. And I showed you how to do that through the terminal on a Mac, because it's Unix-based. It has mail built into it. But in that case, you are the client, and you need to know, you have to have your server set up and all those kinds of things. When you get your phone, right, and it says, we need to set up mail for you, that's because there's a mail client in iOS and a mail client in Android. It's also usually Gmail, which blurs the lines because Gmail can just be a browser-based, right? But if you have a mail client in iOS, you have to know your plain old post office server, right? It's called a POP server. Remember that? And you need to know your simple mail transport protocol server, your SMTP server. And that is for, I'm going to get this wrong, plain old post office servers for incoming email, and the SMTP servers for outgoing email. And this is not the web. This is not the web. This is mail. If you were of a certain age, you might even remember something called Internet News. It ran on a different protocol called NNTP, for Network News Transport Protocol, which ran on top of the internet. And you would have a news client, right, that would go to a news server. And this is not the World Wide Web. FTP, the one I showed you last week, right? I showed you my FTP client that goes to an FTP server. It is not a World Wide Web server, okay? So there's all kinds of things that are the internet that are not the World Wide Web. Okay, and if you don't learn anything else from this whole digression into connectivity, this is really, really important. The internet is not the web. Okay, the web runs on top of the internet. Now, how does that work? Well, the World Wide Web, the www service, was invented in the 90s by a guy at CERN, right? Tim Berners-Lee, right? And the way he invented it was to look at older technology, some of it, actually, most of it, invented and manipulated by IBM for publishing books, believe it or not. And I'm not going to go into it, but believe me when I tell you that when we get to HTML markup, right, and when we look at that, it's almost exactly the same as stuff that IBM was selling to clients in the 1980s to publish books. You just run it through a bunch of different computers, and it would publish books out to industrial laser press or to camera ready copy for actual books at the time, right? And Tim Berners-Lee took a very, very small set of codes and said, we got text on the internet, and I think everybody remembers that from last week. But if I, was smart enough to put a text file with a bunch of tags in it or metadata or annotations that said, hey, this is a paragraph and this is a list and this is a heading, then I could maybe have another piece of information that can read that, another piece of code that can read that with the tags. And by the way, I can put all those files on a server, right? So that the browser can read what's on any server on the internet. Now, for you to understand how this works, there's a couple more pieces of information that you need to understand. First of all, every client and every server on the internet has a number, a unique number, okay? It's called an IP address, okay? So when I say you have an email address, you kind of don't have an email address. You do, but you don't. You have an address that is actually represented by a number, okay? And the way it gets changed into text or words or addresses is something we'll get to in a second. But in essence, the internet and the World Wide Web run on top of this client-server architecture with web servers, right? That's literally what they're called, and web browsers. And you guys all know the web browser, okay? Everybody's got a web browser. We're sharing information right now over your web browser over Zoom, right? But what's essentially happening is that all of the data that we want is going from a web browser over the network to a web server. And in this case, it'll be Zoom's servers, wherever they are in the United States. And that information will get sent back to the client, which is a web browser. When you go to a bank with your web browser and you do online banking, it's exactly the same. The bank has a set of web servers, right, that connect to your web browser, and they interchange information, okay? But at its heart, the way this started and the easy way to understand it is that a web server over here is just filled with a bunch of files and code. It's just text and resources, okay? That's all it is. It's just another computer with a special set of software called a web server. Now, if you want to try this out for yourself, you can. There's lots of web servers out there that you can download and try, okay? And if you have a network connection, you can try setting up your own little web service, if you like. But there's all kinds of them, and just Google web servers for download. But be careful, okay? Because you can do some weird stuff that you don't know what you're doing. The fact is, you have on your own machine a lot of servers and clients built into your own machine, where the machine itself is both client and server. Don't worry about that too much. That starts to get a little bit complex. The thing I really want you to understand is that a web server is just a set of files. That's all it is. And it has this special software called a server, and it goes over the internet to special software called the browser. Okay? And the way it communicates is through a protocol called HTTP. Okay? You've probably seen that, right? HTTP stands for Hypertext Transport Protocol. Okay? And that is the key invention that Tim Berners-Lee added to existing technology. This Hypertext Transport Protocol and the ability for the client to request information from a web of servers that are linked. So unlike systems before it, where you have a single server and some clients, this is the internet we're talking about, where every computer could be either a client or a server in theory. In theory, your phone could be a server. Hopefully it isn't. But in theory, it could be. In theory, anything on the internet with enough power to be a server could be a server and send information. And what kind of information does it send at its core? It sends text. It sends text. So when you look at a page on the internet, any page, doesn't really matter, it could be this page, right? This is just a text file, okay? It is sitting at a server under my hosting domain, right? It's actually hosted by a company called Saratoga Hosting in New York, and they have a bunch of computers with a bunch of clients like me, and they set up the server environment for, for me, right? Under jrtechcom.com, in a folder called courses, I have all the information for COMS 2200. And I showed you that last week, and here it is again, just so you can see. Now, I have in my connection at Saratoga Hosting, I have a number of different websites actually, right? I used to do this at my photography website, which is the root website for this, okay? Public HTML. That website is jamesrobertsphotography.ca, okay? So this is a bit weird, right? I don't have the courses there anymore, but if I'll show you what it looks like. I think I can still do it. Maybe not. Let's see. Yeah, there we go. So do you see I changed the name here? jamesrobertsphotography.ca/courses 2205. Okay, well, right now, I don't have this course running. But this is also a text file that's running under that same environment. It's just running in a different domain. And I don't have to set that up, right? The people that I pay set that up for me. So here it is, right? And here's the previous coursework. There's 2205. That's what we're looking at. We're looking in this folder right here, 2205. Okay? Okay, have I lost everybody here? Does anybody have any questions before we go any further?
No.
Okay.
I do. Sorry.
Okay, good.
Could you kind of, because this kind of confused me a little bit.
Mm-hmm.
Going back to, so the server goes through the internet via HTTP and gets to the web browser, which is the client?
That's correct.
Is that what it is? Okay.
Yeah, this is this web browser is a client, right? This FTP program is also a client. It's not a web client though. It's an FTP client. Do you understand?
Okay.
Right? It's a different kind of thing. I'm not reading any pages here. I'm just transferring things back and forth because that's what FTP does.
Okay.
Okay? So you see this is just files?
Perhaps we can indicate what are we seeing when we see the FTP is the backend.
That's right. This is the back end. This is the server view, right, on the right. Sorry. See, it says remote site, right?
Right.
Local site. This is my desktop over here. So on my desktop, I have an image that's exactly the same, so I can work on stuff and then put it over
Okay.
here, right? So this is
Okay.
this is local, and this is the server in New York.
Right. Okay. So this is basically the background where you
Yeah.
make the changes, and then so this is the FTP, and then it goes in. It's in the web server, though, right?
Yeah, that's right. That is a web server directory you're looking at. Okay. Now I didn't have to set up the program, but all of this stuff is available if you know where to look for it. So let me just give you a demonstration. So we're in 2205 here, and I happen to have a what do I want to show you? I happen to have a presentation called Situm Practical Taxo.pdf. Do you see that? Actually, let's not do a PDF. Let's do an old index here, okay? Everybody see this? Okay, do you see that file? Index underscore 2019W, right? Watch what happens when I put that name in here. Okay. Index, is it underscore 2019? W.htm. Oh, look, there it is. So do you see what I did there, folks? Did you guys understand that?
Yeah.
Right? I'm actually saying this is the text file I want to look at, the HTML file. It's there on the server. Okay? Now, here's a question for you. Why don't I see anything when I just do this? What am I seeing?
Because you changed directories right now.
It did not.
You're in 2205 folder, and
Yeah.
that is a published page, which is what you have right now.
What published page is it?
2205.
Nope, I didn't change directories actually.
So what are you looking at right now?
What am I looking at right now? It's a very good question. What page?
Isn't that the 2205 index?
Yeah, it's index.htm. It's actually a file called index.htm.
Which is the landing page of the folder 2205.
Which is the special page, yes, the landing
The
page.
special page that lands on 2205.
Right, you don't have to specify it. So I want people to understand, right? So there's a special file called index.htm, right? If it's called anything else, like capital and I index.htm, you have to specify it.
Actually,
Okay.
that's a good one. I didn't know that the capital thing too.
Yeah. It's so that's how web servers work, folks. They are just folders filled with stuff, right? And not only that, right? They're folders filled with stuff, and you can specify pages. Okay. So yeah, go ahead.
Yeah, that's. I just want to say that's original web servers. Yeah,
It's just a web server, yeah. And if I want to look at a different page there, index underscore error.htm. I don't even know what that is. Let's find out. I don't even know what that one is.
Also, Professor, are all these the courses required for the certificate? All these
Yes, Bob,
that
they
are
are.
showing?
So there's a different one.
Okay.
And this one is called index error.htm. I'm not sure why, but there it is. Okay, so does everybody understand how that works? Anybody not clear on this? Okay, so what page is this?
Homepage?
Yeah, what page is it?
2200/index.htm.
Correct, that's correct. This is index.htm. Again, I don't have to say it. I don't have to say it because that is understood by the server software to be a special name. Okay? That is your homepage always on most software. There's a couple of others, default.htm on Microsoft servers, but mostly index.htm or index.html means the text file that is called index.htm. And that text file looks like this. You can always look and see it. Okay.
Sorry, you got me confused there. You mentioned index.htm.
Yep.
You also mentioned index.html.
Correct.
What is the difference between the two?
Nothing. Nothing's the difference except that you name it differently. So here, let me show you. Let me go to the
in this particular case that you've done HTML. What if you type index.html? Would that appear still? Or
no, it would not.
Okay.
But if I change this, you see I'm going to change the name on the server to index.html. Okay? It's not going to make any difference. Shouldn't make any difference. See, it still loads. You see?
So it's either one of them as long as someone is set. Okay.
That's right. It's either one of them. But if I now go index.htm, it's going to be an error.
No.
That should be anyway. It isn't though. Isn't that interesting?
It's probably cache memory.
Oh no, there it is. Yep. Yep, it was cache. I have my cache turned off, Harry, just so you know, for these classes, but it didn't work. So you see what happened there, folks?
Awesome.
You have to be very, very careful about what you say, but what you specify. But either one of those is magic when it comes to just having the folder name. And that's all a web address is, okay? It's really this, okay? I'm gonna do this. You see the whole address there? HTTPS, which means Hypertext Transport Protocol Secured, yeah?
SSL.
Yeah, that's what the S is. www.jrtechcom.com. That's my server and my domain name. And I paid for that domain name. Not very much, but I did. And then there's a folder on that server called courses. And there's a folder inside courses called 2200. And this is index.htm. Okay? Now, if we want to, you know, I don't think I can duplicate something on here. Let me just see if I can.
So does that mean for HTML websites, you basically design what the page looks like before you upload it?
That's it. Yes, you got it. So the whole idea is to author it first, then upload it. That's correct. And
it's actually done online.
yeah, okay, so you don't usually do it online. The exception is if you're working in something like WordPress, which does the same thing, but you log into a browser to edit it. And it handles it all beneath the covers. Do you know what I mean?
Makes sense.
Yeah, it's pretty interesting. If I don't think I can copy this. Create new file. I'm not going to do that. Not with live data. It's important to understand, though, that this all works through a series of computational tricks that are not very sophisticated, right? So, for instance, like I said before, all computers have numbers, right? And you can find out what the number is just by asking, usually. So in your terminal, there should be a ping command, right? And if I ping, say, www.yorku.ca, this should give me some information. Oh, yeah, there we go. Okay, did you see? Now, okay, you can time out any time here, guys. Used to doing this on Windows. Okay, so, oh, it didn't work. Control Escape. Anyway, but the point is, do you see this number right here? Can you guys see that okay? 130.63.236.137. if I copy this and paste it into a client, into a browser, what should happen?
Plug into your
Would
Rogers
it give
thing.
a physical address maybe? Isn't it an IP?
Sure,
Or,
yeah.
I don't know.
It's an IP address. Yeah.
Yeah.
So what should happen if I put that in a
Your
browser?
website?
Yeah, it'll go to York.
Technology, eh?
Technology, right? This is old technology, guys. This is the IP address of the York server, the main one that serves the York University site.
How old is it? Like
How old is what?
the technology you said.
The technology for this, Bob, goes back to ARPANET in the 1960s and 70s.
Wow.
We just put a lot of stuff on top of it, right? So you notice it says not secure. That's because this is HTTP. Now, I bet I can do this and spell it out, and let's see if it works. Nope, it's not going to do it. It's going to give me a warning. Might let me do it. Let's proceed anyway. Come on, Chrome. Yeah, it sort of let me do it, even though it's not secure. But you see it automatically added the index.html. So I want you to just take a break for a second and imagine how difficult it would be to use the web if you had to have this information all the time, if you had to have that address information all the time. It'd be almost impossible, right? So the way this works is that if you look at our little client server diagram here, it doesn't actually go web browser, internet server. It goes web browser, domain name server, then server. So there's another set of servers where that www is, and they're called domain name servers. And it's the domain name servers that look up your request, change it to a number, and then take it to the server. Yeah, go ahead.
So is the domain masking the IP address?
The domain is alias to the IP address, yes.
Oh, yes.
So, and they have to be set properly by the domain name owner, or it won't work. Because essentially, the giant table of IP addresses will be wrong. Now, here's a pro tip for you guys who are following along. If your internet is slow, it can be because your domain name server is slow. Right? Did you ever think about that? That every time you make a request, it goes from your browser to a domain name server that you don't even know about most of the time, and then gets the name. So if I go just yorku.ca, I don't even have to say .index, right? Oops, dang it. Thanks, Google, for rescuing me there. Right? It's just going to come up. It's just going to come up. I don't have to say index.html. It'll come up anyway. Right? So there is an actual computer out there, and you can change your domain name server. Again, this is just the pro tip for tonight. So you could use Google's domain name servers if you like. They're public. And they're very, very powerful. You have to go into your network settings and actually add that number as your DNS server in your network settings. Okay? It's pretty interesting. There's all kinds of ways to show you how to do it on the internet, but there's also other ones, right? So you can go to OpenDNS or Google DNS, and sometimes, depending on where you are and who your provider is, that will actually speed up the browsing of your internet. It'll speed it up a lot. Right? It could also slow it down. So I'm just telling you, this is all tricks with computers based on old technology. Okay. Any questions so far?
Yes,
So-
one.
Yeah.
So essentially it's just evolving from like the 1960s to now, like the servers and like what they do.
That's correct, Bob. Yeah. It
HTTPS.
evolves every year. You can see there's over here, there's actually a whole new set of addressing. Right? You're used to this, the regular sets of addressing. Those are the Internet Protocol version 4. Internet Protocol version 6 is the latest that is actually being used right now. And it has a whole different set of addresses. because just like phone numbers, the internet will eventually run out. So they had to invent new protocols.
I have a question.
Yeah. Go ahead.
Do I go?
Yeah,
Okay.
Shivani, go.
So this DNS server would be like a proxy for our web browser?
It's not a proxy. It's a setting in your network settings so that whenever you make a request from the client, whenever you put an address in here, it would automatically go to that domain name server instead of the one that you're set up with Rogers or whoever your provider is. They have their own too, Yahoo, right?
That is what's called a pointer, correct?
Yeah, it's just a pointer. It's just a list of pointers. It says, oh, yorku.ca is whatever that number was, 130. I can't remember now. 130.63.236.137.
I had a question regarding the IP address when you enter it to the browser.
Yep.
How come it did not recognize the SSL?
Because the protocol is specifically set to not recognize a set of numbers. It's not secure.
Oh.
Right.
Shouldn't that be secure?
Yeah, it's not secure. That's why Google threw the warning.
Okay, I see.
Right. You know, that the whole security system depends on certificates being exchanged, and this is way beyond the course, right? But there's an exchange of certificates. The certificates have to be up to date. Browser has to recognize them. Server has to actually have a valid certificate. It's got to be validated by a certificate management system, et cetera, et cetera. So this hack of actually throwing an IP number up is not secure. And it's also not good. Did you notice what I did there? Do you know what a ping is, folks?
Isn't that to determine your IP address when you do a ping?
Well, yeah, but what does it do?
Pinpoints your location?
No, that's a good guess.
How long it takes to reach a server or
Well,
something?
it is how long, although did we get any data back
No.
when I pinged? No, we didn't, right? It's a timeout, which means what?
It didn't reach its destination.
It didn't reach the destination because?
Maybe packet loss or something?
No, it's not packet loss. Clearly, I don't have packet
loss. It's not secure?
It's not secure, so?
It
just won't let it go through?
So the server won't let it go through. The server won't let it go through. Because what I'm really doing with a ping is I'm saying, colloquially, if I say I'm going to ping you, what am I going to do?
Touch you.
Yeah, I'm gonna. Well, no, I'm not. I'm gonna contact you. That's what it means,
reach you.
right? I'm gonna reach you. I'm gonna reach out by messaging or something. That's exactly what the ping command does. It takes 56 bytes, not kilobytes, 56 bytes of data, and sends them to the server and says, "Are you there? Are you there? Are you there? Are you there?" Right? Usually 4 or 5 times.
Cool.
But York's server is set up so that does not work, right? It doesn't work. It timed out. Let me try one more, okay?
Like an old school Facebook poke?
What's that?
Is that kind of like on Facebook? I used to be able to poke people.
Well, yeah, poking people is kind of like that, although it's a person, right? This is a machine. So let me try pinging. Let me ping IBM.com, see if they let it. Yeah, good. Look at that. I'm actually getting data back from IBM.com with little tiny bits of data, and I hope I can stop this.
So what is this data, though?
It's what it is it's a reply. First of all, it's telling me IBM.com is 129.42.38.10. See that? Mm-hmm. I sent 56 bytes of data, and it sent back a response. This, the first one came back in 39.424 milliseconds, right? And what that tells me is how fast I can contact IBM over the net. So it actually went through the DNS server, went to IBM servers, and they're allowing a ping. Okay, now they're probably allowing a ping because they have all kinds of security behind this system, right? So they don't care. But here's the thing. If I was to, say, write a little program that launched ping against IBM 1 billion times a minute, if I had the computer power to do it, what would happen to the server?
It will crash it.
It'll crash it. And that's called a denial of service attack, right? That's happened a lot over the years. Yeah. So all you have to do is Google denial of service, and you can see how this works, right? You get a bunch of requests all at once, right? That overwhelm the server so that the server can't respond, right? And that's how it works. And in fact, this is a, you see the victim over here? The attacker actually controls, this is why Trojan horses are so terrible. They may not be attacking you, but they might be using all your devices and millions of other ones to attack the victim.
Wow.
Just with those little packets of information. But that'll bring down Amazon.com, that'll bring down banks, it'll bring down all kinds of people, right? It really is a huge impact. So that's why York has it turned off.
I have a quick question regarding this. So let's assume that the server is getting bombarded by all these requests.
Right.
There were already connections established prior to this attack.
Correct.
Are those previous connections remain intact, or they also get bumped out?
Well, they remain intact, but don't forget, for the most part, and this is simplified, right? For the most part, the victim servers are real servers. So let's say you're connected already to Amazon.com and you got 10 things in your cart, okay? And just before you press buy or, complete the order, somebody does a denial of service attack. All of the resources of the computer that you're connected to could be taken up with opening new connections. So you could never complete your process.
So everyone gets affected by it.
Yeah, everyone gets impacted by it. So that's why there are, obviously there are security measures against it. One of them is not to use a ping, but there's obviously monitors that try to deduce whether a connection is real or a connection is, an attack. There's also distributed application softwares like Kubernetes, which spreads resources over all of your computers instead of one, so that a server is actually virtual, not just a single machine that can get overwhelmed. But even still, resources are limited. So can you overwhelm a cloud? Yeah, you can overwhelm a cloud if you know what you're doing.
Is it similar to when there's too many people on one, going up on one website and it kind of shuts down?
Yeah, that's exactly what it is.
It's kind of the same thing, right? Okay.
It's exactly the same thing, except that it's only one person who sends a malicious command to 1 million computers at once that says, ping Amazon.com. And I got to tell you, this is so easy to do that a smart 12-year-old could do it.
I don't know.
No, I'm telling you, it is. In fact, if you look inside your own router. Oh, go ahead.
A young kid did that in 2000. He was in grade 9 and he shut down Yahoo.
Yeah, of course. Because it's really, really easy. And once you've got the script, you don't even have to know how it works. You just have to fire it up.
It's illegal though. So.
Oh, it's completely illegal.
So
we're talking about terrible stuff here, folks.
Evil.
Not things you should try at home. But having said that, at home, I don't know if you know how to get to your own router, which supplies your IP address on the internet and allows you to surf the web and do Zoom. If you connect to your own router, it probably has a setting to avoid denial of service attacks. right? Some of the newer ones do. And of course, there's all kinds of ways. This is an old attack, folks. But like I say, this is old tech, right? And you can read about how they worked and how many of them there were. I don't know if there's any news on them. Oh, there you go. Distributed denial of service attacks skyrocket probably during COVID-19. Because people are bored. I don't know. It sounds ridiculous, right? But there it is. Yeah, of course, right? Organizations are more vulnerable because people don't know when they're actually being targeted, right? And they don't go in and change their routers. Anyway, so does everybody understand how that works now? How the client and server works when it comes to these things?
Yes.
Yep. Everybody's good on that? Okay, so here's the deal. There's all this stuff now that runs on top of the web, as we said last week, right? There's so much of it, right? How does it work? How does it work at its basics? Okay, well, what this shows you, I think, is that there's text files and there's resources. Here's a good example of a text file and a resource. The index page that I basically showed you looks like this, right? Don't forget, this is just a text file, right? This course website homepage I've got is just a text file, right? That's all it is. And it has these tags, right? The tags are what the client understands, right? So your browser understands this tag to be a paragraph tag, right? And every time it sees a P like that, it starts a paragraph. When it sees an H2, that's a heading level 2, right? H1 is obviously a heading level 1. And so all an HTML file is this set of text files. All a link is this href, right? This was the big thing that Tim Berners-Lee invented, this thing right here, a href tag. All those other tags had been around before in different technologies, but this one is the coolest. There were heading references like that, but this one is super cool because this is the thing that says, for this text or for this link, go here. Okay? That's what makes the World Wide Web hypertext. That's why it's all hypertext transport protocol. But this is what's on the server, this file, in all its gorpy glory, right? This is actually what that page looks like, okay? The reason you see it like this is because the browser parses all that information in real time and shows you this instead of this.
So can we assume or say that written code like this is for the use of the machine and the front end is for the use of the end user?
Correct. That's completely correct. The only reason this is structured the way it is so computers can read it. And it doesn't even have to be like, I don't know about you guys. I know this will make people's eyes glaze over. But if you look at this, can you at least read what it is? You probably can, right? So you can see that the title of this is COMS 2200 resources. It doesn't take a huge amount of brain power to understand that that's the title of this page. It's what comes up on this little tab. See, COMS 2200 resources. That's where it is, right? It doesn't take a whole lot of imagination to understand that this declaration, this style declaration, is how I make stuff look the way it looks. So for this particular page, the headings look like this, right? They have a font weight of bold, a size of 18 points, and they're either Arial, Helvetica, or sans serif, depending on what you've got on your computer, because remember, it's the browser that has to interpret that, not the server. Okay? So if the font isn't on your computer, it's not going to look right. Fortunately, Arial's on all Windows machines, Helvetica's on all Mac machines, and everything else has some kind of equivalent called sans serif. So that's why this works. Okay.
So the server has all of the text files and it sends it to the client, and then the client translates it?
Bingo. It translates into something you want to look at. And like, it doesn't even have to be this readable. I mean, this is readable because I wrote this out by hand. Okay. You know, in Notepad. I actually did this first one in Notepad. Okay. Everybody got that? I mean, when I started IBM, I used to write books coding like this, literally like this, ULLI for lists, right? That means unordered list, list item, list item, list item, and that little slash means end the unordered list. So you tell the computer when to begin something and when to end it. And that is how it works. You're completely correct. It's just this Gorpy text file, and that gets sent to the browser, and the browser interprets it as this. Now, like I say, it doesn't have to look like this, especially if it's generated by a computer. So let me show you what I mean by that. So let's go to, let's just go to Google. Let's Google. So, Google DNS. Okay, cool. So if what I've been saying is true, right, this is also just a text file. Okay, what we're looking at right now, this whole long address, and it is just a text file. It's come out of a database. It's come out of Google's search engine. By the way, I'm not speaking on behalf of Google here. I really, this is just my own observation, and it's public. I have to say that. But look at the source. You want to read that? You don't want to read that.
Oh, wow.
Trust me. There are some parts in there that are readable.
Somebody actually wrote that?
Nope, nobody actually wrote that. That's all code. That's all code coming out of a database. It's all script code coming out of a database, right? And when it hits the browser, which is Chrome, it looks like that. Isn't that cool? Is there anything in English in there? Yeah, you know, if I do one of these, I bet if I search for DNS, yeah, it appears 276 times in here. So, you know, the information is there. The links are there. Do you see that? Oh, look, it knows my Google account. See that? Jamie Roberts.
Are you logged in?
Yeah, isn't that cool?
Yeah.
So, so the information is there, but that's all generated by a computer. Okay. Let me show you another page that's generated just for the heck of it. I'm sure IBM.coms is generated as well. Its homepage, although it might be a little bit more readable. Let's find out. A lot of script. Oh, look at all those alternative links. This is a lot more readable. It's probably a mix of people who have written things like this. You see, keeping citizens safe during COVID-19 is our top priority, right? And a generated template where people just go in and fill in the blanks, right? Okay. Have I lost anybody yet? Okay, cool. Now, one of the things I wanted to really let you know is that these things, all of these things that happen on the page, right, to make it look like this, are transactions. I mean, they happen so fast, you don't think about the fact that this is a text file, that these pictures they're not in the page at all, right? They're not. They are just another resource on a server that the page says, go get it. And when you load it, it actually loads into the page and the browser arranges it. So a lot of the magic here, folks, happens in the browser, okay? And one of the reasons that Google, for instance, created Chrome, even though they're not a browser company, and then basically gave away the code to people like Apple and other people like that, is because they wanted to advance the user experience of what you could do with a web server. You know, imagine if the world's most popular browser at this point was Internet Explorer. There would be no reason for them to make it easy for Google to create an interesting search page. Okay? But everybody needs to really feel it in their bones that these are transactions. They are actually happening. Things that are connected on the web are actually happening with the help of servers, and they come together in the browser at runtime. In other words, when you look at it, right? Which is astonishing. So if we go back to the source for this IBM page, did you see this? You see this image class, IBM resize image flex, and then look, there's an HTTPS call, i.dam. whatever that is, folder name, folder, something.jpg. Well, let's see what that is.
Women sitting in the backseat of a car using her phone.
Yeah, look at this. That's the picture. The picture's on the server, and it's there. It's at that resource, right?
But who owns the picture, though?
Well, IBM owns the rights to that picture.
Mm-hmm.
So in order to put it in their code, they still have to own the...
Well, that's a really, really interesting question, isn't it? Because, you know, as you probably have guessed by now, if I click on this and I go like this and I click Save Image As, or better yet, Copy Image As, all of a sudden I can put it in my PowerPoint display, just like this. Because these transactions are all connected, right? This is the thing about digital media, right? It's not just copyable, but it's so connected that it's transparent to the user, right? But this actually lives at this site. Okay, now in theory that means I could also go like this. I'm going to copy it, right? And if I put it in a page like our course homepage, which I happen to have here in Dreamweaver, right? I should be able to insert it, right, into my own website like this. Mm-hmm. Let's see if I can remember. I'm going to use the code here, right? Although I wouldn't have to. I could basically just right-click and insert image, I think. Can I do that? Yeah, look at that. I think I can just paste this in. I think, is that right? No, sorry. That could be it right there. Ah, there you go.
That's so cool.
Now, did you see what I did there, folks? I did not copy and paste it. I copied the link.
So does that mean that you don't need to like give credit to where the picture came from? Like, you know,
so do you want to rephrase your question about whether it's legal or not? Yeah, exactly. You have to give credit, and I don't own the rights to this picture. Now, I don't know if it's an open source picture. Knowing IBM, they probably paid for it to a stock agency, which means I don't have the rights to it. But I don't even need to have it on my hard drive. Okay? You have to understand, I didn't copy the code the way I did to put it in PowerPoint. I literally copied the link, which means to show it to you here in Dreamweaver, it's going out to this address on the web, finding that picture and putting it there.
Do I have to know how to do that?
Legal?
What's that?
Is that action legal? If let's say, for instance, you leave it there.
Yeah.
Would IBM say, you know what, take it out?
Well, I mean, would they ever find out is the question. Would they ever look at my website?
Well, they can see the activity of the link, no?
No, they can't. I mean, they can see it if they bother to look at my website.
But if they do see it, is this on the legal side or
this is
not?
complete? So they probably don't own it either. It's probably owned by somebody else. So it's not IBM that would have to chase me down. It's whoever owns the rights to this file. And would they do it? And could they even find out? How would they find out? Do you see this little thing in my HTML? You guys, can you see that?
Mm-hmm.
Robots, content, no index, no follow. Do you know what that means?
Can't trace it back.
Are you telling the server not to, or the browser not to follow you?
I'm telling all robots like Google and other search engines, don't index this page and don't follow any links on it.
You can do that.
I can do that. Now, so
Wow.
this is a real conundrum for you guys, right? This is the transactional nature of the World Wide Web. This is literally what happens in real time. I have no skill. I didn't take that picture. I didn't copy it. It's not on my hard drive. If I save this and put it on my site right now via FTP, if you open up your browser, you will see that. So I'm going to do it momentarily. I'm sure IBM will forgive me for a second. Okay, I'm going to save this. I am going to.
I have a question.
Go ahead.
When you said that you tell the browser not to have any not to index the page or follow any links, do you mean when if somebody clicks on the picture, it doesn't take them to the original source?
No, I'll tell you exactly what that means in 1 second. Let me just get rid of the index file here. Okay, so right now I got rid of the index for our course. I just deleted it. So I hope that's okay. But if I go here, it should show me nothing, right? Oh, it's spinning. Come on. Oh, which one did I delete? That's not good. It's still there. Which one did I delete, guys?
205, maybe.
Yeah, probably 22. No, 2200. But it's the main one. Okay. No, JR.com. Courses 2200. Is there an index there? Yeah, there's still an index there. Sorry. I don't know what it's doing with Photoshop. I just want to delete this. Delete. We're going to delete it. Okay, there it goes. Okay, so it's gone now, right? There shouldn't be one there. Now if I go here, yeah, there's nothing there, right? Okay, everybody see that? Now I'm going to upload the new one with FTP. And the way I do that is just by double clicking on this. Okay, so it's done. Now when we go back, and there it is. Okay, so does everybody see what happened there? I put that picture there. I don't own that picture. All I did was find it on IBM's website and link it. Okay, so if we look at the source, you'll see that link, right? Right there. Do you see?
So
There it is.
when we make our web page,
Yes.
I think there is an assignment too, right?
Yep.
So, and we take a picture from the web like you did here. And we source it in our, like you sourced it in your code for the picture. Do we still need to give the website credit for it?
So the way you would do that, okay, in this course, I don't think you have to make you don't have to make a website. I want you to work on it. I want you to play with it and understand it, but it's not one of the assignments. But if you were doing this for real, you would actually have to have the stock photography yourself. You'd have to own the license to it. If you're doing it for an assignment, most people are not going to care, although intellectual rights would say you should actually credit where the images come from. Okay?
Do we
So if you're
leave
doing
the
this,
picture up until the end of the course to see if anything happens?
what's that?
Do we leave the picture up until the end of the course to see if anything happens?
No, I'm going to get rid of it right now, actually. Sorry.
Fires.
I'm not trying to teach you guys bad things. But yeah, I'm going to do that. I'm going to do something else here because it's not just pictures, right? It's not just pictures you can do this to. It's quite a bit more complex than that. Anything with a URL is linkable, okay? Anything. So let me just delete that, make sure we don't have that available. I'm going to put that back. Good. Okay. So I think we're back to normal now. If I go to COMS 2200, the picture is gone. Awesome. Awesome. Good.